At this time, we will begin with Wes Lee. Wes is our director of the Mesonet program in Norman. Wes, we appreciate what you've done, and I know I definitely was watching in this morning as the tornadoes moved through and was pretty close to my house, and I was glad you had the Mesonet up and going. So thanks very much, and without anything further, we'll turn it over to Wes with some of their applications that they have to help us with our pesticide applications.
Thank you, Justin. I want to make sure first that my presentation's on the screen. Everybody can see it. Justin, are we clear?
Yeah, looks good.
Okay. Well, just 5-6 years ago, I was sitting in Justin's chair doing what he does before I moved up to Norman at the National Weather Center. But I am still an OSU employee, just like Justin, doing these kind of in-services and things. I happen to be in the same boat as most of you guys. I'm trying to accumulate enough in-service hours myself to not have to retest for private applicator. Even though I attend a lot of meetings, a lot of times I don't get credit for them because I'm the speaker and not learning about the material. But I work for Oklahoma Mesonet, and if you're not familiar with the Oklahoma Mesonet, I'm going to show you quite a bit of the material for that. I don't have enough slides to keep us going till 8 o'clock, but I'll give you a full overview of the Mesonet program and website and some new features that we've just released in the last couple of weeks. So advancing through the screen here. We are the weather system for the state of Oklahoma. We were established in 1994, or officially went online January 1 of 1994. And we've been recording weather data and presenting it to the citizens of Oklahoma every 5 minutes since that time of January 1. It is a program that's jointly operated by OU and OSU. We received part of our funding to continue the program before the two universities get their money. So we're up the line a little bit, but it's a joint operation. We have 3 advisors from OSU and 3 advisors from OU that continue to give us direction for the program. We currently have 120 public weather towers across the state. There's at least one for every county. The average spacing across the state is about 18 miles apart. Most of these towers are on private property across the state. Depending on where you live, your tower will either be on private property, or it could be, for example, an OSU research station or an OU research station. For most of the talk today, I'm going to focus. I know I recognize the names of some of you on the Zoom tonight there. I know a lot of you live in Cleveland and McLean County. So tonight we're going to use the Washington Tower for most of the demonstration purposes here. At the Mesonet Tower at Washington, in fact, any of the towers across the state, this is the different categories of weather parameters that we measure. So just about anything weather related, we're going to have it on the tower to take a look at. In fact, most of these different parameters, we have 2 different sensors or a duplicate set of sensors to record that information. If you can see the little circles on the screen here, this happens to be the air temperature reading that is at a standard height of 1.5 meters or about 5 feet, the one on the bottom. And when you see temperature on the news at night, it has to be recorded at that particular height at 5 feet or 1.5 meters. But we also record temperature up towards the top of our towers. Our towers are 10 meters tall or 33 feet. We're recording air temperature also at the 9-meter height, and I'll explain why we do that later on in the program there. But other sensors like rain gauges, wind sensors, we usually have 2 of them in case one of them goes out or gives us trouble. We don't lose that measurement on that particular location on that day. Here's the tower at Washington, and I would venture to guess that very few of you have ever seen this tower. I was the county ag educator like Justin for 10 years in McLean County, and I never saw the tower myself. I often wondered where it was at and why I never saw it. With the name Washington, you would think it would be close to the town of Washington, and it is, but it's 6 miles away, and it's in the middle of an OU research station. I didn't know OU even had research stations, but I came to learn that they have 2 of them. One of them at Norman, and this research station at Washington, where they do all kinds of weather research and test out different instruments. So to get to this tower, you have to have access to this research station. It's a lock gate, and this tower is just very difficult to see unless you happen to be on that property. You can see here, every tower, we have a location descriptor. So you can see that Washington Tower is 6 miles southwest of Washington. We even have the longitude and latitude. There's aerial photos, topographic maps on each one of the towers. If you want to get to that information, you go through the About tab on the website. I'll point it out to you when we get there in just a minute. At the Washington Tower, you can see these variables here, these weather variables that are recorded every 5 minutes. It's basically everything weather related above ground. We take a reading every 5 minutes and send it to our clientele in approximately 7 minutes from the time that it is taken. You'll have that information on your phone or on your computer screen. Now, for the variables that we record below ground, those take a little bit longer to accumulate. So soil temperatures at multiple depths, we get a reading from the tower every 15 minutes, and soil moisture takes even longer. We only get one reading every 30 minutes from the towers on soil moisture. But good thing about soil moisture, it doesn't change very quickly like air temperature does or barometric pressure. So 30 minutes is actually pretty good. We happen to be one of the few weather systems in the state that even make the effort to record information below ground. We actually have more trouble with the soil sensors recording this soil temperature and soil moisture than all of the other sensors put together. That's because of lightning strikes, gophers, the clay soil cracking and swelling. We just seem like we have issues with the sensors all the time. But because we are the OSU involvement to the Oklahoma Mesonet, we think that soil moisture and soil temperature is vitally important to our farm community. So we make the effort to try to get that data out there. Here's our website. It may look a little different than what you've seen if you've been to our website in the past. There, because I'm showing you our new website. You get to our website, you can see I've highlighted here at mesonet.org. Now, I will say that Mesonet is not an Oklahoma term. There happens to be about 28 or 30 other states with some form of weather collecting system that they call Mesonet as well. But because we are the oldest, the largest, and the most continuously running system, anytime you go to a search engine and type Mesonet, you're probably going to get the Oklahoma Mesonet. But that's our website domain, is mesonet.org. Tonight, I'm showing you what's called a beta website. So if you were to go to mesonet.org on any browser, type it in, it's going to pull the old website up. But at the top, there's a scrolling banner that says, if you want to try our new website, click here. And the reason I'm showing you the new website is because in January, the old website will go away, and this beta site that I'm showing you tonight will take the place of mesonet.org. So it's what we call a hard release. It'll take the place of the current mesonet.org. So we didn't want to waste time showing you the old website when the new website's going to be the only thing you see when we get about mid-January on. I'm locked on to the Washington Tower here. This was, I captured these slides earlier this morning, so it's not current data, but it is from today. If you want to change to any of the other 120 weather sites across the state, you would just click change, and it gives you the option to select any of the other towers. Now, there's lots of different categories of data on our website. We're going to walk through some of these different tabs. I told you earlier, showed you some of the information about the tower at Washington. that would be underneath this About tab, and then you go to the station name of Washington, and then you can see that information. But we're going to start over here on the left-hand side under the Weather tab. And once you click on that, our new website looks like this. The reason we changed websites was, well, there are multiple reasons, in fact, but one of the biggest ones is our current old website is not ADA compliant. So we had to go through a lot of steps to make sure our new website is ADA compliant, that people with limited visibility can have screen readers, things like that, that can handle our website. So it looks a lot different. It's more icon based. It actually kind of resembles an iPhone when we go through the screens, as you'll see here, is how we've set this up. So I'm under the Weather tab, and here you can see the different parameters, weather parameters that have all of the data for each of those different things to look at. Now, most of the time we present weather data in a map form. There's lots of ways to get data. It could be a graph, a table, something we call a mediogram, but maps make sense to most of us out there because we can readily tell on a map where we live in the state and what the weather is with us, and kind of what's going around to our neighboring weather towers as well, all at the same time. So I just pulled a smattering of maps up to look at real quick tonight. This is rainfall for the last 30 days. Again, you can see I gathered this morning. So if you lived, let's say somewhere east of I-35, you might have got a little extra rainfall after I grabbed this map this morning. But for most of us, this is what we have accumulated the last 30 days. Now, I'm not going to zoom in and do this, but you can probably see on this map the pixelations, or the little squares with the colors. We have 120 rain gauges to collect rainfall data, but if we had 1,220 rainfall gauges out there, we would still miss some of the rain events. So to kind of take up some of the gaps in between the weather towers, we get this color overlay from the National Weather Center at Tulsa, the River Forecast Office. They take our real-time gatherings we get from the rain gauges, and they actually calibrate the radar on the fly. So about an hour or two after the rain event is over, we get this color overlay to put on our maps. It's a 2.5 mile grid in there. So yes, rainfall could vary within that, that grid as well, but that's as high resolution currently that as we can get out of a radar. And if you're in between two Mesonet towers, you can look at these 2.5 mile grid picture or colors and get a pretty good idea. In fact, it's about 97 or 98% accurate of what the rainfall is, at least right above where the Mesonet tower is. So we actually have 64 different rainfall maps that update every 5 minutes. So everything from 1 hour to 1 year and everything in between, you can take a look at. Here is an air temperature map again from this morning. Of course, these update every 5 minutes, so you can stay up to speed on what the air temperature is happening during the day. Relative humidity, a big parameter for us in agriculture. Knowing what that relative humidity is, you can see that as that front moved that Justin talked about, the severe weather, had a drier air mass behind it. So you can see those relative humidities in the panhandle this morning were already down into the 30s, whereas eastern Oklahoma at this time was still getting rain or socked in with fog. So relative humidity are very important for us, especially on drying hay and things like that. And then when it comes to applying herbicides, which is we're going to focus on tonight, wind speeds are one of the big parameters that we're really worried about. So this was this morning's wind speeds, not only wind speed, but wind direction that you can see from the arrows on the state here with that. So there's just a sample of the maps. We actually have somewhere around 200 maps that update every 5 minutes on the website to take a look at. So not only do we have those 5-minute maps, we have what I'm going to refer to here as value-added maps. So this is where we take a lot of different weather variables and put them together into a product to try to do some kind of farm and ranch management or any kind of management out there in the state. This one that's up, this is currently, it's not a current map. It was last summer. We don't worry about this particular topic of wet bulb globe temperature risk in the wintertime. It's simply a map that we put up every 5 minutes that is the best indicator out there of heat stress. So if you're going to have a heat related problem, this map will tell you where that's going to happen in the state. You don't get too worried about the numbers on the map. I kind of focus on the colors. So anytime we start getting black on this map, you need to be careful about hydration and trying to get out of the sun when you can, whenever you get the opportunity. Another value of added map that I've shown here is something called temperature inversions. I showed you the two different temperature measurement devices, the one at 1.5 meters and the one at 9 meters. We use that height difference to determine temperature inversion. A temperature inversion is anytime we have a warm layer above a cool layer. It acts as a cap, and these maps tell us when that occurs, at least at the Mesonet tower. I know this map is pretty busy, but just focus on the red on the map, not the red circles. Those are missing data points, but the red on the map, like this +1 for our county or for our part of the state as of 9:10 this morning, was in a +1 temperature inversion. We'll talk more about temperature inversions in a little bit. Okay, back to the website. We're going to jump now to the forecast tab. If we're going to go out and put a pesticide out, we kind of want to know what's going to happen over the next day or two, so that we don't have a drift situation. 2, we want our product to work properly and not get washed off or not do any good. So we're going to take a look at the forecast tab on the new website here. Again, it's this icon based look, and we'll look at a few of these different features. First of all, this local and regional forecast opens up a page that looks like the old website, or if you're one of the people that uses our app that we'll talk about towards the end, it looks very similar to you. So just a 5-day synopsis of the forecast. For agriculture, unfortunately, it's not precise enough. And when I say precise, I mean by the hour. Looking at a daily summary doesn't do us much good. For example, on this Thursday, you see wind speeds are expected to be 7 to 13 miles an hour. So sometime during the day, they're forecasting 7, and sometimes they're forecasting 13. If we're putting a product out that says apply when the winds are less than 10 miles an hour, we can't tell by this forecast when we need to do that. So we're going to look a little more precisely here. First, I want to say that the Oklahoma Mesonet is not in the forecasting business. Our job is to collect real-time weather information and to store that data to be used, the historical data to be used for research, or anytime anybody needs historical data. We are not forecasters, but we have this relationship with the National Weather Service where we give them all of our data of the real-time measurements, and they give us access to some of their forecast products. So to get that more precise or more time-sensitive forecast, we can either click this button that says hourly graph or hourly table. So I'm going to take a look at the graph here. Now, I wanted to show you the graph, but there's nothing. This is not a current graph, so don't think that what's showing up here is fixing to happen over the next few days. In fact, this is back into September. But up at the top, you see these blue check marks. There's a lot of boxes you can click on or off. If there's too much data on here to focus in, you can click everything off except temperature or probability of rain or whatever you want. If this was a wintertime month, instead of September, it would also have the chance of snow and freezing rain to take a look at as well. So that can be really important to us out there for forecasting and planning our activities. But the reason I pulled this older map is because it has rain on it. So our forecast for the next 2 or 3 days didn't have any rain in it. And I wanted to show you what rain looks like on this hourly forecast map. So a lot of places will show you probability of rain. Very few places will show you how much rain we're expected to get. You may have a 60% chance of rain and it rains 3 raindrops, and yeah, they were right. It did rain, but it didn't impact our farming operations. This gives us a little bit of an idea of how much it's going to rain over a period of time. So this 3-hour block that I'm highlighting here is only 0.06 of an inch, but it gives you an idea of how much rain you might accumulate during that period of time. And one other nice thing about this gridded graph, if you put your cursor anywhere on the graph, whatever hour you're pointing at, it'll give you for your location a nice little text graph. So if you're going to be doing something, let's say you've got an outdoor birthday party coming up in 2 days, you can go to that point in time on the graph and it'll give you a pretty nice quick text synopsis of what to expect at the weather, at least at this point in time. Of course, the further out it is, the less accurate that forecast is going to be. Moving to the next icon back on the forecast page, it says the forecast temperature. So here we're used to looking at maps again. Here's the forecast temperature for tonight. Probably going to be freezing for half the state and not for the other half of the state, according to the forecasters here. The next tab is precipitation forecast. Now this one looks a little different. It's not necessarily numbers or anything on a map. It takes a little while to kind of figure out how to read these. But as of 9 o'clock this morning, when it was still raining in eastern Oklahoma, this is the 1-day precipitation forecast. So for the next 24 hours, as of the time I grabbed this map, you can get an idea of what rain they were expecting in that part of either your part of the state or eastern part where it was still raining. There are precipitation forecasts from 1 day to 7 days, or accumulation of like 3-day accumulation, 5-day, 7-day accumulations. You can look at these precipitation forecast maps out there. All right, the last thing I want to look at under the forecast map is this long range, but do notice there are other, like Justin mentioned, severe weather forecast and fire weather and winter weather forecast to take a look at. But let's look at the long range category. Here they presented in a U.S. map that looks like this. There is precipitation outlooks and temperature outlooks. You may have saw these if you watch Oklahoma Sun Up with me on Saturday mornings. We use these maps a lot on that. This is a month forecast that I'm showing you here. They have 1 week forecast, 2 week forecast, 1 month forecast, and 3 month forecast. And again, the further out you get, the less accurate these forecasts are going to be. This 1 month precipitation outlook is for the month of December, but it was made on November the 30th. So it's important that you know not only what it's representing, but when was this map made. So now that we're halfway through December, the map would look a lot different, but you have to know that the 1 week and 2 week maps come out every afternoon about 2 o'clock. The monthly and the 3 month forecast either come out twice a month or once a month, depending on the product there. So that's important to know how long it's been since this map was created. Okay, back to our website. Now I want to look at the past data tab. We're just kind of working our way through. We're only going to look at 1 or 2 more locations here, but here's past data. If you have a need of past data for any reason, this traditionally is where you would go to look at it on there. There's lots of data. Remember, we started in all the way back to 1994. So we have data going back a long ways there. I'm only going to show you quickly 3 different places where you would maybe take a look at that past data. First is what we call a tower summary. And this is a monthly summary. I'm on the Washington Tower. There's something blocking my screen. I can't tell what month. I think this is November, but I can't see the top of the map here. If I'd have pulled up December, it would only be half filled out, but you can look at a month it's not completed if you want to here. One of the nice thing about these maps is down at the bottom, you have some summary information. So if you need to keep weather data, I know I got a lot of clients that say have a lagoon that are supposed to keep rainfall data. This suffices for that, just to be able to print this one sheet off and take a look at. Sorry about that. I had to have a little drink. Okay, back at the past data, looking at the long-term average maps is where I'm at now. So you can see on the screen, I'm looking at 2022, July, air temperature and maximum air temperature. So this is what the month of July came in on a monthly average. But you might be saying, well, for Cleveland County, is 99 degrees hot? Of course it is, but how hot is it? Just 2 clicks. One, if we click this little departure from average button and then hit display map, then it shows you how far off or how hot was that month looking at. So we can see here that July, yes, it really was pretty hot. We were 6, 7, 8, even 9 degrees above normal. When I say normal, that's in this case, it's a 15-year average. So it's 7, 8 degrees above the 15-year average. The thing about maps, the only thing you have to remember, it has to be something that's already completed. So I can't look at a map for December 22. I can't look at fall of 22, but I could look at summer of 22 or any month in 22 other than December. And these maps go back, I believe, to 2008 that you can get data on a monthly basis. The last thing is, on the past data is a graph. This is our long-term average graph, and it is the most powerful, but it's also a little bit confusing to take a look at. This is what the screen, just a screenshot of that. You can look at any weather variable out there and compare one site to another site. We can look at rainfall and soil moisture, anything we want to graph, we can graph here. I've got Washington rainfall, cumulative rainfall for the year showing on the screen. So the blue line is the long-term average, and then that black jagged line is what we've actually had to date this year. So if I put my cursor on the end of that line, it pops up. You can see we've actually caught up quite a bit in the last month. We're at Washington now, we're only about, it looks like about 2 inches below the long-term average at that particular location. That's not the case in a lot of locations, especially further out west, where some of them are 6, 8 inches behind normal for this time of year. One more thing about the graphs, there's a little what we call a stacked hamburger button. So you can graph anything you want to, go into this hamburger button and download the image, or you can download the data if you're one of the Excel people that really likes to use Excel spreadsheets. 2 or 3 clicks and you can have the data right into your Excel spreadsheet in columns ready to go for you. Now, one other thing about any of our graphs, not just the long-term average, any graph is zoomable. So you just highlight with your mouse the area that you want to look at. In this case, I just looked at September on that same rainfall map. So you can kind of zoom in and see that data a little bit better there, what's going on. Okay, back to the website. The last tab we'll look at tonight, this is the agriculture tab. And as Justin mentioned, I'm the agriculture coordinator for the Mesonet. This is where I spend most of my time. We've spent a lot of work the last 2 years developing and working on some of the products that are under agriculture that are now on this new website. So I mentioned the reason we went to a new website was ADA compliant is one. The other reason is that this new website is mobile friendly. So you can pull this website up on your cell phone, your smartphone, or a tablet, and it'll work just as well as it will on a computer screen to take a look at it. It automatically resizes for whatever device that you want it to look at. So that's another neat feature of having some of these ag tools on your cell phone that we never had access to them before without going back in the house and looking at them on a computer. So underneath the ag section, there are tools or value added advisory decision-making tools in a lot of different categories. I think there's 16 different tools in total. Tonight, I just want to focus on the drift risk or spray drift product out there. We call it our drift risk advisor. So because we're talking about pesticides and pesticide drift, let's talk about that. Again, this tool works now on any device, any smartphone or tablet, just as well as it does on the PC in your house. I've already mentioned we're going to have a full release in January. That's when this new beta website will become the current website. It's on there now, though, if you wanted to play around and use this. One big change we made on the drift risk tool from the old tool is that we're focusing on inversion. And I mentioned that twice already, so we're going to talk even more about inversion now. Why inversion? Why all the attention on inversion when it's talking about herbicides? Well, every herbicide product that comes on the market today is going to have a statement on the label, something similar to this. This is the label I have up is an older version of the XtendiMax, dicamba product that goes over the top of cotton and soybeans there. But all herbicide labels now are going to have a statement similar to this. It's going to probably tell you what wind speeds are legal to apply in, as this one says 3 to 10 miles an hour. And it's going to say, do not spray during an inversion, or it may say, do not spray if an inversion is imminent in there. And this particular product now, the new label says you can only apply 1 hour after sunrise and 2 hours before sunset when an inversion is not happening. So what is a temperature inversion? I've already mentioned it's just a warm layer of air that acts like a ceiling or a cap. So if we were applying herbicides that volatilized, or we were putting animal manures out, or we were talking smoke in a prescribed fire, if we have an inversion layer, those products get trapped close to the ground surface and they move laterally, and they can move very long distances. It is not uncommon for herbicide drift to move miles, not just hundreds of yards. We're talking miles when we have temperature inversion conditions and the right kind of product. Normal conditions, when we don't have that warm layer, then the product actually dissipates and can go up into the upper atmosphere. And this is a picture from this summer by my house, one of the producers here in McLean County, that you can see the temperature inversion. And a lot of labels, when you ask a herbicide, a chemical company, how do you know if an inversion is present? Well, they'll say, look for smoke or look for fog. That happens about 2 times a year out there. The rest of the time, we have to have another method of trying to determine when inversion. But you can see on this picture here, it is a flat line. That's the temperature inversion level there. The sun's up, so it is after sun up, but we have this temperature inversion going on with this fog situation. Back to our inversion maps for Mesonet. Again, I want you to focus on the upper right-hand quarter of it's either going to be a blue number or a red number. And this is just a day in the past, just grabbed a day, September 25th, 2018. I want to look on an hourly basis to see how that temperature inversion changes. So we're going to start at 1 p.m. on this day. You can see as it moves through here, we start to see some red show up. Sometimes it comes and goes. And this is going to end sometime on the next day at 10 a.m. in the morning. Remember that XtendiMax Max label said 1 hour after sunrise. Well, 10 a.m. is going to be well past sunrise, but we still have these red numbers at different parts of the state, especially out west on this particular day. So legally, we would be against the label if we put a product out in those particular areas that had a temperature inversion going on. The bad thing about inversions is nobody forecasts them, or nobody forecast them accurately. There's some people who have tried, but there is no accurate inversion forecast. I can tell you with Mesonet when we're under an inversion, and I can tell you when we've been under an inversion, but I can't tell you in the future whether inversion is going to happen or not. Typically, they happen every night, though. So that's why the statement on the label about 1 hour after sunrise, 2 hours before sunset. Sometimes we get some really strong inversion situations out there. I've actually seen this number up into 14 or 15 before, plus 14, plus 15. I remember that happened in one of the freezes we had last year when we had pecan trees that froze up to about 2/3 of the height, yet the top third of the tree still had nuts on it from a springtime freeze there. So we get those strong temperature inversions that happen Here I've got a +10 circled. A +1 is just as bad for herbicide drift as a +10. The only thing the +10 tells me, it's going to take longer for the conditions to break down to where we no longer have that temperature inversion on this particular setup versus if it was a +1, we could go out of the inversion pretty quick, or we could go deeper into an inversion and be at this +10. We don't know, but I do know a +10 is going to take a matter of time before it breaks down and goes away. So this is what our new website looks like on an iPhone 12. So just gathered some of these pictures off of my phone. I want to show you it works very well on a phone and kind of what it would look like. So here's the home page. If you say of the Washington location, it's not today, but you get the idea. Up here at the top, you'll see the stacked hamburger button again. I don't know the scientific name for that, or technical name, but that's what we call it, stacked hamburger button up here. Once you click that, it opens up. It looks like the web page then on a computer screen where the stuff is spread out. And we're going to focus under the agriculture tab because that's what we were just talking about. We're talking about herbicide drift. Once you click the agriculture tab, it looks again icon based, so you can see some of the different categories to look at. To get to the drift risk monitor, it's under the crops section. So we click on crops. You can see the crops that we actually have some of the tools for in it. The drift risk tool is actually in every one of these, so any of the crops would work, but I'm going to just select the first one, alfalfa, to take a look at here tonight. So once you click on the alfalfa, you see some of the tools that we have for alfalfa growers. The one that's pertinent to our discussion tonight is going to be this Drift Risk Advisor. So kind of navigated how you would get there on a cell phone. And once you open up the Drift Risk Advisor, this is what it looks like. So not a lot of color on our screens, again, because of that ADA compliance. We're trying to check every box we can so everybody can use our products and tools. This is written out in steps. So you'll see here on the screen, there's step 1, select your Mesonet site. If you've already used this tool, it's going to have whatever site you had on there last. I've just pulled up a blank one. So you would see you've got a pull down button on the side so you can select any of the 120 sites for the first time and it'll stay there. Next, you select your request type. So we've created 3 different radio buttons that's different than the old product. So this is the new version. You have current conditions, past data, and forecast. So I'm going to start with the current conditions and show you what it looks like. And when I hit the Get Data button, it opens up something that looks like this. We have wind speed, wind direction, temperature, and whether or not we're in an inversion, red or green. It's color coded for the inversion. I designed this for our commercial applicators, say in an aerial cockpit. They could stick their phone in the cradle, and as they're out working, every 5 minutes, they get a new push of weather data, and they can tell then every 5 minutes whether they're in a temperature inversion at that particular tower, and whether or not that wind speed might be above what the herbicide label says that they're supposed to stay under. On here, each one of these 3 boxes are what we call hyperlinks. So if you click on the inversion box or temperature box, it opens up the statewide map. So if you're that aerial applicator and you're moving from one location, one field to another, and you want to see what the towers are maybe closer to where you're going, you can quickly look at the full size map right there on the hyperlink button. So that was the current conditions tab. Next, I want to look at the forecast tab. I'm going to skip past data. We'll come back to it in just a minute. The forecast tab then has you to do a step 3, and that is to select how far in the forecast you want to look at. I've defaulted everything. If you don't want to enter data, you don't have to, but if you can change it if you want to. 48 hours is the default, but you can go out to 84 hours if you want to take a look at the forecast. Next, you have to, this is a little bit further down. It wouldn't fit on the screen. So it's just as you scroll down, you'll see you have to enter in wind speeds, air temperature, and rainfall. Again, you can take the defaults that I'm showing you on the screen here, 2 to 10 miles an hour. But if you want to say 2 to 12, if that's what your herbicide label says, that's where you would change it on this particular screen. Lastly, you have the option of selecting wind directions that you want to avoid. So once you just, since this is on an iPhone, you use your finger. There's 8 different pieces of the pie. In this particular example, I have trying to look for times in the 48-hour forecast when the winds are not blowing from the north. Let's say you're one of these lucky producers out there that have a grow operations, which are all over the state on the south side of your property, and you're doing everything you can to try to keep from getting sued from them. We may want to look for an example like this and try to look for forecast hours that have a southerly wind and not a northerly wind for this particular example. So once I hit the get data button, it's going to give me a table. But before I get there, I want to just point out, and this label, this thing pops up all the time. You guys know that forecasts are not perfect, and this forecast tool is not perfect. So your local conditions should supersede whatever this tool tells you. It's just a planning tool to help you find hours to get ready to go out and spray. But once we get data, we get a screen that looks like this. Now, it won't all fit on the screen here, but you can see up at the top, I've got arrows on this iPhone example to scroll left or right, or you can use your thumb to move left or right or up and down to take a look at the data. Notice that on this example, November 30th for Washington, I've got some red boxes there. Did it meet my conditions? No, it didn't. And these where this red box is at. Well, the reason it didn't, you can see a little bit of red in the wind direction column. I'm going to show you what it looks like when I scroll to the side. You can see there, here's in red why it didn't meet my conditions. So the winds were blowing out a northerly direction on this 4 p.m. example. And then when you get down, 11 p.m., 12, 1, obviously we're probably not spraying then, but our air temperatures were actually below freezing. So remember, the default is 32 degrees on the air temperature is why that box turned red. Okay, the last thing I want to show you on this tool is the past data. I'm really proud of this feature. It's new, it's totally new. It wasn't on the old tool. Keeping records, as you're going to hear next week, if you come back and hear the talks, record keeping is extremely important. And I think keeping weather records of when you put the application out could be very beneficial to you. Some things you're required to do, some things it's just in your best interest to have that data to defend yourself. So if we click the past data radio button, we call it, again, we can pick a time period. It defaults to 48 hours and 1 hour interval, but you can pick a 5-minute interval, a 1 hour interval, or a 3 hour interval, I think, to take a look at. You have the option then of using the current date and time and just going backwards from right now, or you can select a custom date and time of any time from the time that tower was put into production. So for most of those towers, that's January 1 of 1994. So I picked use a custom date and time. When you do that, it opens up a calendar and a clock so that you get to pick a date and a time to take a look at. I'm going to look back at February 20th of last year of 2021 on that. So here's what happens when you get data. You have access then to that historical data anytime you want it with just 2 or 3 clicks of a button. So as you can see, this is February. I did at February 21, but if I scroll down, it's going to be, it'll start at 18 and go to February 21. It goes from the point you put in backwards. And so that's why it's back to February 18th. You can see the weather data that's readily available. Again, we can get this on 5-minute data if you want it. It's up to you. And notice that inversion. It kind of got cut off here at the title at the top, but notice we have inversions. So this could help you or hurt you. If you have a lawsuit against you for herbicide drift, this could be used against you, but it also can get you out of trouble, or would be some more data for your defense. If you said, I did everything proper and I did not apply during an inversion, we have some material to back you up. So if you're not familiar with inversions, I think you need to become aware of them, because I think it's going to be more and more pertinent in herbicide drift cases going forward. In fact, in Arkansas and Missouri, it already is the predominant weather factor that's hitting the courts that deals with a lawsuit situation. Okay, we have an app. You heard me mention that before. I know a lot of you on here use our app. We're going to continue to support the app, so it's out there for Apple and Android in the future. Just when this new website comes out, we're not killing the apps because a lot of people love them. I will tell you that once you get to using the mobile website on your phone and have all of the tools and all the data features on there, you may decide you don't want to use the app anymore, but it will still be available if you do. So here's what the app looks like again on that iPhone 12. I'm on the Washington Tower. If you don't want to be on Washington, or if you want to see another tower, you just hit what I call a blue ship wheel button in the upper corner, and that opens up the 120 sites to choose from. Down at the bottom, you have you can look at maps and radar and weather advisories. Here's an older map, but I like it because of the color. You know, if we were putting a product out in McLean County and knowing that this cold front or this wind shift was coming, probably wouldn't be a good day to put a herbicide out under that situation. You have access to radars anywhere in the continental U.S. I'm on the Oklahoma City radar. Again, this was this morning as that rain moved east. But if you click that little blue tower, you can select any of the National Weather Service radars. If you're traveling across country, you have access to all of those towers. In Oklahoma, we have, we only have 4 towers, but there are some other towers real close to us, like Shreveport, Little Rock, Arkansas, or Fort Smith, Arkansas. So several towers that still provide input to us. This is another device that we have here, another website. If I wanted to show you, because we are going to kill this one in January. If you happen to be one of the people that use this, currently, if you type in Mesonet from a cell phone, it's going to automatically pull you to what this was an older mobile Mesonet site. So if the product you use looks like this on your phone, know that sometime by the end of January, it's probably going to go away. So you're going to have to learn how to use the app or our new mobile website. So just to let you know, there'll be a point in time where this no longer works, probably before the end of January next year. Want to leave you with one bit of good news. I think our weather pattern is already kind of shifted and changed. November came in cooler than normal for the first time. At least as high temperatures, the first time I think in 13 months, we had a month come in on average cooler than normal as far as high temperatures. Rainfall November and December to date has been at least normal or above normal. So I really feel like we're headed in the right direction. But I wanted to leave you with this last slide. We've been under a La Nina weather pattern for the last 3 winters, or this being the 3rd winter. That La Nina typically means warmer than normal and drier than normal for us in Oklahoma. You can see that blue line. This is the forecast projections of La Nina. We get into January, La Nina neutral become a 50-50 chance. We get into February, then a much stronger chance of neutral conditions showing up. That tends to be whatever's normal for us for spring. I hope we have that coming up. And also notice the red line starting to build as we go into spring and into next year. That's the El Nino. Typically means when we have the fall and winters that are cooler and wetter than normal. So there's at this time, looks like a fairly strong probability that we may be headed that direction next winter, which could be some good news for those of us that have some dry ponds and situations like that to deal with. So just a little bit of forecast news to leave you with there. And with that, Justin, I'm going to stop and stop sharing my screen so I can answer questions or whatever we want to do.